My name's Carol Willing, and I'm actually really speaking on behalf of our core JupyterHub team, which includes Chris and Yuvi and Min. And as far as Red Hat goes, as Diane mentioned to some of you folks earlier, Graham Dumpleton has done a lot of work and has been a great help to us over the past couple of years. And sorry, there's like a big Air Force jet flying across. So if there's some background noise, I am not in my normal spot. Okay, so let's get started. One of the things I wanted to do was to sort of explain to folks, even if you've seen what the Jupyter tools are, you may not know sort of where Jupyter comes from. There's some misconception out there that we're a big corporation. Actually, we are the core group of Jupyter developers are in this photo here. Project Jupyter started in academia, and that's where our roots really are. We are funded by a number of research grants and a few industry partners. But what you see in that slide is really the core of Jupyter, and we have many, many contributors beyond that. Our vision is really to help facilitate data science, scientific collaboration, and open source tools with which to do that. And so with that, I will sort of move on. Those are some of our funders, and our mission is really to focus on usability, collaboration, and reproducibility. And in the sciences, reproducibility is key because you need to be able to either show a government agency or other people doing research in a similar area the fact that you can get to the same answer even if you're working on it 3 months later, 6 months later, a year later. So one of the interesting things about Jupyter is it lets you construct a computational narrative, which you can share with other people, whether they're in your industry area or scientific specialty area, and it really helps with solving problems that span multiple disciplines. For, I think, the benefit of the people that might be watching on YouTube, a notebook is basically a combination of narrative text, which is done in Markdown or LaTeX, and code visualizations. And when I say code and visualizations, it's really being able to execute code on the fly, do visualizations on the fly, as well as embed things like YouTube videos, other information that might be useful. There's a recent academic paper that analyzed 1 million different notebooks up on GitHub. There's approximately 2 million up on GitHub right now. So this has grown really quickly since about 2014, 2013. Some of the things that we see are people developing interactive content for large education classes that maybe traditionally haven't had animation embedded within it, but actually by adding animation to their lectures actually makes it a much more powerful story. We're seeing machine learning being used in a number of areas, including medicine, media, finance, government, and things ranging from scikit-image, PyTorch, TensorFlow, and many, many of the other rich libraries that are in Python, R, Julia, and other languages as well. In fact, one of the Nobel Prize winners at NYU has put together a comprehensive course based on notebooks and which can be taught in either Python or Julia, and it's really quite a fantastic series of notebooks. So moving forward, JupyterLab extends the concept of notebooks into more of a multi-windowed, web-based extensible user interface. So you can have windows. You can pull visualizations out of a particular notebook and have it off to the side where you can manipulate it. Concepts, things like scratch pads, and really the way you can maybe have prose on one window and actual calculations and other things on other windows. So it's really taking the notebook, the classic notebook, which we like to call it, and extending it in many different directions, and also having the ability for users or companies to extend the actual notebook functionality through plugins and other things. And you can try that on Binder, and I'll get to what Binder is in a little bit. JupyterHub, which you can run on OpenShift, and there are a series of great blog posts by Graham Dumpleton and GitHub repos that go with that, that explains how you can do that easily on OpenShift. And JupyterHub is basically the way that you can, if you have a group of users, that you can give each person in that group their own notebook server so that they don't have to deploy, things locally. They can actually work off a web-based instance and in the cloud. And particularly in education or in a research group, that's very powerful because you can pre-install all the dependencies that you need and have the same environment or customized environments for each person in your research lab or in an educational setting. And there's different methods of authentication, different ways that you can what we call spawn a notebook server, which for one size doesn't fit all, and our supercomputer, high performance computing users may have very different needs than somebody working in a small data science team within a company of, where the data science team is maybe 10 users. So it is very flexible and extensible. And what we have done in the past year is we have developed a Zero to JupyterHub guide, which uses Kubernetes, and the guide itself sort of assumes that you've got a functioning version of Kubernetes on your cluster, and then it walks you through how to use Helm and the Helm charts that we provide to deploy JupyterHub so that you can use it within your own organization. Similarly, Red Hat and OpenShift has a way to basically deploy the same functionality, but doesn't necessarily rely directly on the Helm charts that we have. But underneath of those, that there's very similar functionality. The architecture of JupyterHub is essentially there is a proxy to the outside world that takes in information from users. It will authenticate users with the hub. It will spawn up, in many cases, Docker containers that will give each user their own sort of sandbox, if you will, in which to do work. And there's also this notion of services where you might have a third-party service that you've developed. Maybe it's a way to share reporting or presentations, and it's something that communicates with the hub, but it's not doesn't directly reside within the hub. This particular slide I'm not going to dwell on, but it's an example of how JupyterHub is being used at Harvard with large classes of students to do electronics and wearable and Python instruction. And it's pretty cool, so worth checking out later. Binder is a new grant that we received last year, and the concept behind Binder is you put in a URL or a GitHub repo, press a button, and it will launch an ephemeral notebook or environment with which folks can compute. And it was funded by the Moore Foundation. And the reason is more to provide a mechanism with which folks can share reproducible research. So you would maybe have a research paper, you would stick in a badge or a link to a binder instance. By clicking that link, you would then go and it would take all the data that was used to generate the research within the paper, all the calculations, and we are seeing great interest from the scientific community, and things ranging from the notebooks itself being used, our studio being used, Julia, and Nature has done some profiles on it, and some other information as well. Because we realized that some people wanted to build their own binder service, maybe to serve notebooks to an industry research group. We also have, similarly to the Zero to JupyterHub instructions on deploying your own BinderHub. And down the road, we hope that all the different BinderHubs, at least in academia, will have some sort of federated model behind it where it really opens up open research and collaboration. The BinderHub architecture is very similar to JupyterHub running on Kubernetes. It's a little bit of extra functionality. One of those bits of extra functionality is something we call repo2docker. Those of you that are familiar with OpenShift may have heard source to image that Graham put a lot of work into, and actually repo2docker is built on some of the concepts that Graham put together with that. And we had a great meeting with him last year that really moved us forward in terms of sort of being able to specify and then build Docker images for custom data science and scientific programming environments. So we're very thankful to Graham for that. And the documentation for repo2docker, you can use repo2docker either within BinderHub as part of BinderHub, or you can also run it locally and build your own images and mix and match different dependencies that you might need in order to do your research. And that is pretty much the basics that I had. I am happy to answer questions. I wasn't anticipating to go into a real deep dive, but I did want to sort of let folks know that we are a nonprofit. We are very much focused on research and the needs of scientists and data scientists across the world. And, we are very much committed to building open tools that helps people using machine learning be more effective. And that's pretty much what I had, Diane.
Well, I think it's a great introduction. I'm curious from my own perspective and join too. So I'll mute a few more people. I'll mute everybody again and see if people have questions. So if you want.
This is Dave Ronchek from.
Hi, Dave.
Hi, how are you?
Good.
I think this is amazing. Really, really cool stuff. I noticed you were using Helm, and I was wondering if there was also Kubeflow packages available for all this good stuff. And if not, can we help?
We have been working with you guys on the Kubeflow project, and
okay,
I know you're using JupyterHub within that project. And we anticipate, as we move forward, that there will be more collaboration. right now, I think we are somewhat limited just by the fact that we are a nonprofit
Okay.
research project in academia in terms of resourcing big efforts, but we are happy to provide knowledge and
Okay.
work with community members as well. So I think
No,
it's
that's
great.
great. Yeah, my hope was back on that architecture slide. The thought of folks having to do all those various proxies and things like that. That's certainly what we were hoping to try and tackle with, or make much easier anyway, with Kubeflow. And so we are more than happy to help, get your packages into Kubeflow and make it easy.
That would be great. That would be great. Yeah, and I mean, I think one of the things that we've tried to do, even within the Jupyter team, is we recognize that scientists and data scientists may not be computer scientists and may not be, fully versed in DevOps. So we want it to be able to, with minimal provisioning effort, to be able to just sort of, much like you would download an app from an app store, get to a point where you can have a fully functioning cluster with a number of data science tools available, and TensorFlow being one of them, PyTorch, scikit-image, Julia, Python are what we have found in our working with both folks in industry and in education and academic research, that really there's not one particular tool that folks rely solely on. They may work primarily in one, but they wind up using all of them in terms of data cleaning and data analysis. So
yeah, there's no question. We've already seen that in Kubeflow. That's why Kubeflow is designed to support PyTorch and XGBoost, scikit-learn, NumPy. We already have upstream contributions for that, and so for us, more than anything, is making sure that we would love to get your stuff in and connected to whatever a data scientist wants.
Absolutely. Totally I will also be in Copenhagen, so we'll have more time to chat more in detail about
this
specifics.
Is great. I can't tell you how many times I've heard people ask for exactly what you've just demoed here. This is really, really cool.
Cool.
So you mentioned Copenhagen, and I will put a pitch out here again on May 1st in the evening. Carol and David and Diane Fedema and a number of other people will be at the 6 to 8 p.m. reception that we've set up for everybody from this community and the Kubeflow community to come together and have a beer and hear some lightning talks and talk about ML stuff on Kubernetes. So if you're coming to KubeCon EU, please do join us that evening, and I put the link to that in here. Are there any other questions for Carol other than huge kudos and what do you need from us, maybe, Carol?
I think just, I think some of the things so continue to support Kubernetes, because it has really, as a whole, streamlined how quickly and efficiently we can deploy things. I mean, there's still a ways to go, and Kubeflow sounds like a very promising way to get to, as well as some of the other projects like Service Catalog and some of the other things being done in the Kubernetes world that will make users from a variety of different academic and science and data science arenas more productive. So I am very pleased, and I'm very much looking forward to meeting all of you in person in Copenhagen too.
Maybe if I can add something. This is Guillaume speaking from Laval University in Quebec City. It was not for a question, but for big kudos, because that's exactly, as end users, as data scientists, that's where we want to go. What we are, we already use Jupyter and JupyterHub, and inside Compute Canada, we are teaching to the researchers to use those tools, and that's great. And what we're trying to achieve in this new project is put the glue in all those tools that we have. So having JupyterHub spinning notebooks inside containers, and what we're working on right now is the other part with Spark, with Matt and his team is doing with Red Analytics, to have at the same time spinning, a complete environment from scratch, having the notebooks directly connected to Spark. We have, because we do mainly medical research and things like this, we have to isolate different environment that we'll put on. And the idea to be able to spin containers on demand and having directly the notebooks connecting to a Spark instance that would be spun up at the right time with the right connections, the right credentials and everything, that's what we want to put inside the hands of the researchers, because they have to do research, not to tamper with all those tools that they have to build. That's the concept of science apps that we are trying to develop, and we are relying a lot on all these tools. So thanks a lot, Carol, for what you are doing. It goes exactly in the right direction, especially with Binder, because we want our researchers to manage their code, because now science is code. We want them to manage it in exactly the same way that IT people are doing, with versioning, with all those kind of things that are brought by code management that they currently don't use. So we have to put all this in between all these different tools. That's what we are trying to achieve, and Jupyter and all the things that the people are doing here on this call are very great for us. So that was a kudos from the end users.
That on behalf of the entire Jupyter team, thank you. And it is really what we're trying to do is not just, and I think you captured it well, just not just the tools, but also moving. We recognize that science is moving more and more into the computation space and into open tools and cloud computing, and there's an education piece within the communities as well to deliver these solutions effectively and in a way that people understand. One of the things with scientists is if you deploy something and you're not quite sure you deployed it correctly, you're not going to want to have your research, over multiple years rely on something that you're not sure is working. And I think that's where Kubernetes and Kubeflow and other projects really help take the DevOps stuff from the scientists' hands and put it more into people who are very experienced with that, whether they're working at, whatever companies, Microsoft, Google, Red Hat. OpenShift has done a lovely job of the one-click kind of install. So, and Compute Canada is doing great stuff, not just within science, but also looking at education in the younger grades in elementary school and as well. So kudos to all the work you're doing.
And it's not only helping the scientists taking the most of all those tools, it's also help them not to have the burden of setting this up, because normally usually the way it works in a new lab, okay, we want to have to do some calculation in Spark, whatever libraries you are using, and we want to set up notebooks and things like that. Usually what they do is they task grad students to set up all the environment, and it takes months and it's difficult. They have to relearn from scratch, and we know for sure that's not an easy task, and that's 1 month, 2 months, 3 months of time that is totally lost for research. It's only time spent on infrastructures, and it shouldn't be the case.
Right. And that's where I hope, to Diane's question of what can the folks on this call do for us, is really put a strong emphasis on outstanding documentation, because it will, by having outstanding documentation as well as good design underneath of the core technologies, it will make it so that the usability will be such that folks can get their work done with a minimal amount of DevOps effort by grad students or professors or students for that matter.
Mm-hmm. You're totally
right.
right. Documentation is really important. And here, I don't think he's on the call, but Graham Dumbleton did a fantastic job. He's my god right now because of all the work he has done and documented. It's really great for us.
Yeah. So
Yeah.
Graham wanted to be here, but it's 3 a.m. in Australia.
Yeah.
So, and he has done some really good documentation. I will find the blog post and put it into. There's a whole series on Jupyter. Yeah. Thanks, Matt. And he's just posted that into the chat. But we need to do more. Our problem, I think, at OpenShift, and I'll admit this openly, is that we sometimes document by blogging. But what we really need to do is get it into the documents on OpenShift docs.OpenShift, and even I'm thinking they get it into the Katacoda posted Learn OpenShift stuff. So there's some work still to be done.
Yeah. I'm happy to help with some of the documentation stuff, like maybe like we do an hour or two sprint in Copenhagen and pull together some of the Kubeflow docs and really, make it so that people can get started quickly. And I think that is, all of our goals. So.